Steven is going to present his work with MakeSense boards and how to incorporate them into Scratch and how it provides an on-ramp for physical computing, for Internet of Things, and various other topics.
I'm Stephen Lewis, and kind of a long and bizarre career, starting with children's book author, filmmaker, for Sesame Street, that sort of. Went to architecture school and became an architect for a while, and then I got the bug when AutoCAD and other CAD systems first came into architecture, and I kind of just drifted completely away from architecture into computer sort of self-taught programming and hardware design and all that sort of thing. And then I ended up back in education for the last 15 or 16 years, teaching computer science, which is what I do for a day job, and love it. And sort of inventing other things on the side, sometimes things I have absolutely no idea how to go forward with, but I just bite the bullet and try it. That's sort of the case in here. So the product that I have now, enabling product, is this MakeSense Board. It's a sensor interface board, which means you plug in sensors, you plug it into the computer, and it is very easy for students and teachers to be able to incorporate physical computing into their projects, whether you're inventing something kind of interesting or a user interface for an existing game you already love, or whether you're coding in Scratch or an advanced programming language and you want to incorporate sensors. It also has a whole other area I call MakeScience, which is subdues the programming component and the open board component, but it actually allows you to make measurements of scientific typical science lab measurements of temperature, wind speed, movement, acceleration, whatever. So that's kind of the broad area, but in some sense I was a teacher who saw a need for, a board that was somewhere between a Makey, which is a lovely thing, but has quite a bit of limitation, and an Arduino, which is a fantastic thing, but is pretty hard to teach. And some people find it really impossible to teach. It's just too much to learn first in terms of programming before you can get to the creativity part. So I think what I was trying to do is create something that will open up the world of physical computing, sensors, to kids who wanted to create and invent, but didn't necessarily feel that they had to become computer programmers first before they could do something interesting. And of course, Scratch fits into that bill. You can start off as a third grader inventing stuff within the Scratch world, which is really lovely, without having to go through what you used to have to go through, which is lots and lots and lots of complicated learning before you could become a creator and inventor. So that was the idea. And it is very plug and play. I have these dangly things here, which are the various sensors. So what you get when you want to use the MakeSense board is the board itself, a USB cable, and a group of sensors that come with it. So part of the usefulness of what I've put together is that I have a lot of interesting sensors, which I've sourced from various sources inexpensively. This is cheap enough so that you can really equip your classroom very inexpensively with this guy. And so what I'll show you in just 2 seconds is how you start up with the heartbeat sensor. So here's one of my sensors that I deliver. I'll just kind of show you how easy this is to use. That's the heartbeat sensor. It connects to, you have to open up your chest. No, seriously, you put it on your earlobe like this, and you plug the little white connector into the board. So I'm just doing this so you can see, wow, that was easy. And that one goes into one of the 8 channels that are around the outside, up to 8 sensors. This is just a standard USB cable, a micro USB. I'm going to plug that in and plug this into the computer USB port, like that. Okay, 1, 2, 3. To get started really quickly, I have a Scratch Studio. You all know what studios are. They're named groups of Scratch programs that people have created. And I'm going to go to the MakeSense Studio, search. and it's the top one, the official MakeSense. There's some unofficial ones here. For instance, Deb Ashman was one of the great MakeSense inventors and users, and I'll show you, maybe if I can, I'll show you one of the movies. She has her own MakeSense Studio as well.
Steve, can you zoom in a little bit?
Sorry?
Can you zoom in a little bit?
Yes. Let's see, can I do that? Yeah, there we go. Okay, so some of the things that are there are about 20 startups, sort of, and some of them are more advanced than others, but I'm going to show you the simplest one, which is the heartbeat animation, but it's an interactive animation. Is that good enough, Cindy? Can you see some of that? Let me just load this. Sorry, you're not supposed to be able to read the fine print. So here I've clicked on the heartbeat one. So we've gone to the MakeSense Studio. We have a heartbeat. I'm going to show you the inside of the code. And let me zoom in on that, which Scratch makes fairly easy. That is the entire code required to make this show my heartbeat. Okay, so if you're working with kids who have very minimal Scratch abilities, and they can do this very simply. Plug, 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 and your heartbeat's going. They could make the cat, they want to make the cat jump. They want to make 2 heartbeat sensors connected, and I'll show you something fantastic that Deb did with that, so that they can compete with each other. So what's the code here? When the A key is pressed. Now, if I press the A key on the keyboard, it does the same thing. So what I tried to do in the kind of simple get started right away Scratch mode is when you connect a sensor, there'll be a number of different keystrokes that the sensor will trigger through the board into the computer, and the computer is essentially fooled into thinking that whatever is coming in from the sensor is a keystroke. So this says when the A key is pressed, set the size to 150%, make it bigger, wait 0.2 of a second so it doesn't collapse immediately, play the sound pop, which I don't know if you can hear, set the size back to 100%. Or it could simply be when the A key is pressed, have the cat move 10 steps every time the heartbeat goes off. That's a 2-line program in Scratch. So part of the idea was to be able to get kids, they love starting with the heartbeat because it's their body and it's really cool. So that gets them started right away and writing some simple programs in Scratch that they can see responding to the physical world. Some of the sensors that are available for this is a distance ranging sensor, just so you get a little bit of a sense of what these things can do. If you're making this can tell the computer a series of keystrokes that vary depending on how far away your object is. Could be your hand, could be kids standing farther or closer away from a fix. So there's part of the aesthetic is the idea that you can take this thing and you can glue it onto a piece of cardboard, or you can connect it with tape. I like the idea that they're taking these sensors and integrating them into some sort of construction that the kids might make. So that's the idea of the extension of the Scratch universe out into the physical world. If you wanted to make a Harry Potter, magic wand thing with this, it would be very easy to do. You could put this in a sort of a hat, and have a little rabbit and flush rabbit or something. I mean, that gets a little silly, but the idea is to connect up not just the sensors themselves and see what they can do, but to begin to integrate making into the full panoply of what you can do with Scratch. Some other sensors, photocells are really good. So these will just connect up, and there's a series of keystrokes, which I'll show you how that works, that are connected to the different channels. So it's all kind of, when you start out with this in a simple mode, you want to make it really easy. The keystrokes are pre-programmed for each of the channels. So they can simply say, oh, channel 2, that's a B, or an A, B, C, D, E coming in, or it's an F, G, or it's a space bar, or it's a right arrow, left arrow. And I have those kind of preset up from what most kids would want to do. So photocell, again, just a little cable connects to this photocell, and when you change the amount of light in any way, whether you use a flashlight or whether you cover it up with your hand, you'll get a different series of keystrokes coming in, so you could make sounds, music, make things change on the screen, and that sort of thing. So that's kind of the general overview of the base level that works very nicely with Scratch.
Can I ask you a question?
Yes, please.
When you first started showing this idea to people,
Yeah.
you didn't have it already connected to keystrokes then, did you? In the very beginning?
The history of this goes back to the initial device. I think I have one here somewhere.
Because I think this
Went
is so
in.
powerful now.
What?
I think it's so powerful and effective.
Yeah,
now. And
I'm not
don't
sure I did
remember
think
in
of
the
it. Maybe
very
it came out of
beginning.
conversations. Because the
I think
original
in the
device went
beginning-
into the microphone port of a portable device.
Yeah.
And I still have that one, but this one is so much
But it
more.
didn't go immediately to
interesting.
keystrokes. That
Um,
feels so, keystrokes and channels, that relationship.
Maybe not.
That feels very
Maybe not.
easy and powerful.
Yeah,
And
I-
manageable.
I made it so that the start, yes, you're right. I think I did come to that later, but now it's the base level where you always start. It gets much, much more sophisticated as you go sort of to
Full
other.
disclosure, I've been following and admiring this for a long time, but I think it's only fair for people, I mean, one of the things I admire about his project is how he stuck with it over time. Which, I mean, I guess in all fairness, if you're a teacher in a classroom, you can't beat yourself up for not staying with stuff, but thank goodness people like Steve are in the world to help people like me survive, in the classroom, so.
Well, thank
Thanks
you.
for sticking with
I
it.
did get lucky in the sense that I don't actually know that much about hardware design. And I guess one of the side stories is here, how does an ordinary teacher who's a good but not super level computer programmer and doesn't know too much about electronics either, get an idea, find other people who can help him make it and throw a year's salary into it, but that's the hard part. But I found a hardware engineer and I have some software engineers, and these people are excited about the project. I mean, I do pay them, but it's, I don't know that much about this, but it came out to be a solid product. And I think what I brought to it was the idea, can we keep it really simple? How would a teacher approach it? What's the best thing for the teacher? So from the pedagogical point of view, I think I had a good idea, but I couldn't have done it without other people. And then we did the Kickstarter, which a number of people here contributed to, so that helped out. But with the days of I don't have any investors. So here it is, it's a product. I went out of pocket, but I'm not broke. You get an idea, get excited about it, and you find some people to help you, and it's doable. So talk to me next year if I'm still solving things. Let's see if I can. I just wanted to show you.
By
a
next
little
year,
bit.
we'll all be able to use this and make you famous.
Yeah, as long as you're happy, I don't care about famous. What I'm showing now.
That's all marketing.
It is, it is.
I mean, it's cool.
I kind of want to show you behind the scenes what's going on in the 8 channels. So this is another piece of the puzzle, and it's actually very nice to show this to kids because now they can visualize what sensors are doing. So if you look at the channel 0, which is on the far left, that's my heartbeat. It's making, let me do one tiny thing.
Can you tell us how you got to this?
How did I make this program?
How did you get to this window? Like, how could we get?
Oh, if you go to the website, again, it's really nice to start with the simple stuff, but the more complicated stuff is there, and I'll show you. MakeSense.co is the website, and you have to download and install the software if you want it on a flash.
If you download it, the keystrokes aren't pre-programmed. Like if you get a board, they're pre-programmed.
Yeah.
Is there a way to put just all this up on the website so that you can just download the pre-programmed one once your kids completely make a mess? You can just set it up
Yes,
again?
I have that as a Chrome extension, which
Okay.
I will show you how to. Yeah. If your kids, in other words, your kids are going through this process
Yeah, I
and
put
changing
those-
it. Okay.
yeah.
So the simplest level is. It comes pre-programmed with keystrokes. You look at the little chart, you see, I want this potentiometer, I'll show you that in a second, to be key right, right arrow, left arrow, or I want to use the AB, and you just write your Scratch program to take care of those. The higher level this is actually the keystroke assignments that it comes with, and I'll just read these off because they're probably really hard to see. Channel 0 is A and B. The 1 and 2 key over here, I've broken the entire sensor value set into multiple keystrokes. So depending, what I'm doing is holding this thing farther and closer from my hand. It's on channel 2, that's 0, 1, 2, and it's triggering off a number of different keystrokes. So it's not just on or off as it would be with the heartbeat, but a number da 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 da. Yeah, if you can learn to sing properly, then you can really have some fun. So this one's broken into 8. These are broken into 8, and this is right arrow, left arrow, and empty in the middle. That would be really useful if you wanted to make a steering wheel for a game, such as I did here. The board. Underneath here is a potentiometer. That's just a volume knob, variable resistor. You get one with the kit, or you can get one, well, you used to be able to get one at Radio Shack till they went out of business. This is just a Tupperware top that's glued on top of that. So when I turn this little steering wheel to the right, it's sending right arrow as if you're holding down the right arrow key. Turn it in the middle, it does nothing, so you don't have to steer left and right. Turn it to the left, it's left arrow. So you glue this on, you plug this in, you plug that in, and you have a steering wheel. This guy will work with any game, not just a scratch game. So now you start to move into the invention. Well, I really like Flappy Birds. I want to make a thing where I can do this and control the birds jumping up in the air. So now without programming at all, you've begun to engage some of the kids in thinking of and custom designing their own interface for a game they love to play. In this case, they're driving games that just use right arrow, left arrow, spacebar. Those are all pre-programmed into the board, excuse me. So if you plug in the right things in the right spot, it's pretty easy to do, and cobble together or something, then you can make your own physical interface. So these are the sensor values, but this in and of itself is kind of interesting for the kids to see what is the gradations of a sensor, and then theoretically, when you want to use a sensor for something, you might have to break it into pieces. So they can just to visualize this on the channel 1. This is the photocell, and I'm covering the light up with my hand, and you can see that it goes kind of from low to high. And the numbers from 0 to 255 are being displayed right here. You can't see them, but that's very instructive for kids to start thinking about what the sensors do, how do they give you numbers. If it's a heartbeat sensor, it's just all or nothing. That's a completely different kind of sensor from an analog range sensor that might be measuring the entire distance or the entire amount of light. So this is just heartbeat is on or it's off. So this is actually, it's a clunky user interface, but this is if you wanted to completely program what the keys did, or you say, oh, I really need the Q key for some reason, it didn't come with that. This is a little program, and I can show you later if you want, how you can divide the sensor ranges. You can visualize the sensor ranges, divide them into zones, and then assign your own keystrokes to it. Sean?
So when you assign a keystroke, or this value on this particular sensor will map to this particular keystroke, that setting, is that a setting that gets set on the board, or that's a setting that gets set on the computer?
No, it's all saved back to the board.
Okay,
so
yeah,
as
so
soon
you
as
can
I
set up the
configure
boards.
this with my own custom design of settings for whatever reason, and it is really easy to do. So you have those set up, and it's basically like file open, file save, except that the destination is the chip itself. Because it's connected to the USB port, it's communicating with a chip. You modify this, you go, it's right up here, it's a set EEPROM. Well, it probably should just say save, but.
If you want to do it for 20 of them, then you just have to connect 20 and save.
Yeah, yeah, it doesn't take long. We do have a Chrome extension that makes this also another. You can save an entire set and then just plug them in. But
okay.
yeah, it's easy. Take my word for it. So that's how you, and I'll show you. So the other thing that we decided when we split this up into two, which I think is really great that we did, is if people I have enough boards and sensors and everything for anybody who would like to play later on. If there's time and people want to stay instead of going out into the most gorgeous day in the world, which I would not blame you in any way, but I brought a ton of sensors, a ton of boards. It'll run on your machines. We can do that after whenever Sean designates. That's the extra time. But I think we have the room till 2:30, and I'm happy to stay if anybody is interested. So that was the original concept for the workshop, was to be very, very hands-on, and I can try to wrap up shortly. Sean, when would you like me to stop?
You have another 25.
Okay, that's perfect. Okay. Good. So,
may I please?
Yep, please ask.
This is the first time I'm ever hearing about you and your great work, and I'm missing something.
Okay.
Okay. So I need to hear at the beginning how this started, because I'm missing. I understand you created the little circuit board.
Yeah.
That, say, hypothetically, I could purchase.
Yeah.
For my classroom.
Yeah.
And use with my students.
Right.
Okay. So how did you develop all of that? Because there are other programs out that do similar things
Right.
with less technological skill.
Give me one example so I
Little
can.
bits.
Okay. So I had several goals with this. Little Bits, I think, is got.
Click it together, it's like.
You click it together and you can make little
the
motors.
lights go off and on. And
Right. So vis-a-vis that, I felt that it was an extraordinarily expensive toy.
Oh, I see.
Out of line expensive. So that's $300 and this is $30 kind
Oh,
of
I see.
scale.
Okay,
I mean, that's not an exact fair.
But that's the good.
That's not the
I'm
good news
yeah.
for everybody.
I was wondering, but now I get it. Yeah.
So
I get it now.
there's price, there's proprietaryism. Their thing, I guess you could make it with they have like a blank little bit or something. I mean, I don't want to.
It is open source, you can
Yeah.
make your own.
Yeah, you can. Right,
Yeah, but
you
yes,
can
I-
make your own.
That's
Good luck.
wonderful.
What I tried to do was make it as open and freely interchangeable as possible.
Your one board is $30?
Yeah.
Okay.
Yeah, and
So
if
a
you
class set would be.
glass set, it goes
30.
down to I price it wherever you want, until I go out of business. I'm gonna keep lowering the price. It's
And how about the
$19 for 10. $19
But the
yeah.
sensors are extra?
Yeah, depending on what you
that's
get.
fine.
So I
I'm good
have, no, that's
Now I
okay.
get
So,
A classroom pack complete
Oh, there you
sensors,
go.
$290.
For him?
yeah,
Well, the Little Bits is.
But you get 10
Is $250.
right, but you get
No,
10 of
classroom,
these.
That's a class.
Oh, a
This
class
is
set.
the whole
Okay,
thing.
stop, I'm good, I'm good.
No, that's okay. Little Bits
All right, I
is,
got it.
no, that's okay. Little Bits is a great toy,
I'm smart, but I'm
and
slow.
they also can do outputs, which our next board can do. So the next question you might ask is, okay, I've got all the sensor input. It's going into the computer, it goes into Scratch. That's so easy, that's cool. What if I want to turn a motor on when somebody brings their hand near a sensor? And our new board, which is almost finished in terms of the software, the hardware is done and works. Our new board is going to support that. But again, in a little bit different way. So let's say you built a castle out of cardboard and you wanted to add lights and motors on top and make a sensor so that this makes a doorbell sound or that kind of construction project, then that's what we would address with that. So we are not going to have a Korg synthesizer in our panoply because they have that. They have a different focus, a different price scale, a different way of going about things. But same general sort of.
Thank you.
But you can get LEDs to light up off of yours.
Oh yeah, yes.
With the
Lights, motors, buzzers, you name it.
No, I mean with the board now.
Oh,
If you hook them up just right, so when the sensor goes to high, you can grab some of the.
she's a genius. She knows how to do everything.
Very good, thank
I
you.
think the realistic comparison would not be Little Bits, because that's in a different category. But the existing board, Makey and Eco Board.
Right.
Right,
Right.
exactly.
So how do you?
So my target was to make something that did more than Makey, which wasn't hard. And no, Makey is a fabulous thing, and the kids are totally absorbed. I don't know if you know what it is, but you can make musical sounds out of bananas and stuff like that. So I have the banana sensor. If you're really obsessed with fruit, you can do that with mine too. And Arduino, which is extremely capable, more capable than my board, but you have to learn a programming language before you get anywhere. So that was my target. Pico is somewhere, I guess, in the middle, but it doesn't have a lot of.
I think they're not.
Yeah.
I mean, it has,
It has some sensors built onto the board. Yeah.
saying this to criticize, but
Yeah.
to sharpen up how you position it.
Right.
I think, the focus, in a lot of different directions here. Pico it has sensors.
Yes.
It has analog sensors.
Right.
Makey is essentially digital. I mean,
Right.
it's on or off.
Right.
Okay. I think another one that comes to mind is once you get outputs going, is Hummingbird.
Right.
Yeah.
So there are a number, let me just finish that. So that there are a number of boards out there that are quite versatile, and they're in the $180, $200 range. Something like a Go-Go or a Hummingbird, in my opinion, they're really sort of blueprint oriented, which means you kind of have to follow their blueprints unless you're really at a very advanced level, and you're a high school 10th grade or 11th grade.
Hummingbird.
Well, let's just postpone this because I have some more things to cover, and then we can pick this up in the follow. Let me just see what else I wanted talk about, okay, so let me divert a tiny bit to MakeScience. MakeScience is exactly the same board, except for science teachers, and maybe it's a little less relevant. I think you've seen how this connects with Scratch and programming languages, and I can go into more detail in the workshops if you want to see how it works with processing, or JavaScript, or Python, or anything else you might be working with. But in the world of science, my experience with science and math teachers is that seeing a naked board like this makes them very nervous. And, oh, that's electronics, I don't know. So the MakeScience board does exactly the same sensor gathering and digesting that this board is capable of, and it is the same board, except that it comes with, instead of a programming interface, it's a data logging interface. So its competition would be Vernier, Pasco equipment, these highly proprietary things where you're seeing how fast their car can go down their track with their light sensors. So I sort of attack that again on the price point, because those are 10 times as expensive as mine, and this is affordable. And honestly, you know, you give this to a student and you say, I want to try, put this in boiling water, and you know, well, if you break it, you're only out $19. It's okay, give it a try. You know, well, I want to drive my bicycle over it. Well, maybe don't do that. But you know, it's really, it's not throwaway money, but it's not considered to be highly expensive, highly proprietary equipment. So, and I'll show you what kind of things you can do with that. So this was on the invention side, where you really are kind of working with a program or programming language. Now we're just measuring wind speed. And this extremely expensive apparatus here, which probably costs 82 cents maybe, is an anemometer. And this is a brake beam sensor, which is one of my sensors. And this is the cable that goes back to the board. And every time one of these cups goes past this, it will send back a keystroke. So all you would have to do in Scratch or in any other language, again, if you're working in Scratch, is say, you know, how many times did the A key get pressed per second? You have a timer, you have the A key, and you've got wind speed. You need to figure out, you know, ask the weather department what the actual wind speed is right now. You need to calibrate it a little bit, but in terms of, you know, making things that can measure speed of, you know, very simple toy cars. I was going to bring my ramps and my toy cars today and everything. This sensor knows when something went past it. So if you had two of them here and you scotch taped them onto a piece of cardboard and you took your toy car and put it here, you'd be able to very easily see what the elapsed time is between the two sensors and compute the distance and the speed, the acceleration. We can get, I mean, if you drop a tennis ball between two of these, we can get the gravitational constant, G, 32 feet per second, within about 2% of its actual value. So it's very, here, pass this around, this is fun. So in the science world, and I'll just kind of stop right after this, I think, I want to show you our data logger, if I can do that, because as I mentioned, you know, people in the science teaching business in middle school and high school, some of them, like, well, Mike's really a computer science teacher, Mike Zemansky, who was here, but you know, they want a kind of something they're sort of familiar with, which is a data logger and a sensing machine with sensors that's kind of in a box. They don't want to feel that they need to learn to program. They don't want to feel that they need to do anything with electronics. Honestly, just looking at that board makes them nervous. So we put it in a box, and then we run this data logger, and then we go back to a good old-fashioned earlobe thingy, and that is on sensor 0. So I check, this is the data logger for science, in case you know any science teachers. And we start it running, and that is my heartbeat right there. A little bit wonky. I think you guys are making me nervous. Now, well, that's nice. Let's get a nice train of pulses. Let's stop that. Let's scroll back through the data to the beginning of time. Let's find a nice series right there. Let's see what my heart elapsed time between beat and beat is. Oops, sorry. Click here with the measuring tape. 0.537 seconds between beats. And if I want to change, so this is a data logger. This is very similar to what comes with the high school, middle school and high school science equipment. But it's open. You can, you know, Vernier, Pasco, those guys. You can, it's very DIY. You can set up your own experiment with thinking of how you would measure something, or build yourself a crazy anemometer, and you get the data logging, which makes the science teachers not nervous, because they love this, they think this is great. They can write it to a file, they can import the data into Excel or a graphing program, so they're happy with that. That makes them, you can set the sampling rate. I mean, I haven't gone through the whole panoply of, I use that word 12 times right today. We have moisture sensors. You put them in a plant, you let it run overnight, you can see what the transpiration, or if that's the right word, of the plant's loss of moisture was over a period of time. You can do evaporation experiments. So there's about 15 or 20 sensors that are generally versatile, but they also tap off into a lot of different types of physical quantities that are really fun to work with. So, questions?
So, I'm still getting my mind around this.
Yeah,
Pardon me if
too
this
much.
is a goofy question, but, so I'm automatically thinking that it'd be cool to use something like this for like body activated sort of gaming kind of stuff. So, like, how it, like, is this just like an output, like, hey, this is what's happening?
Okay.
Is, like, how would information go between, say, that and like making the other things happen? Does that make sense?
Yes.
Okay.
In a Rube Goldberg kind of way, or in a Scratch kind of way?
Well, I don't.
Okay, so with the new board, as an example, you will have to do a little programming in Scratch. So if I have a Internet of Things playground, dollhouse, castle, whatever, and I want to see what happens if, a character was walking by and the motion sensor went off and beep, 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 or the doorbell rang, or the lights went on, or the light sensor turned on the lights when the light value fell below a certain level. That's all doable within the new I/O board, which you haven't seen. You would, in that case, be writing some simple programs in Scratch that said, if sensor 1 is greater than reading of 50, then send a command to turn the LEDs on, or the buzzer, these little piezo buzzers, or something of that sort, or turn a motor on. So is that kind of what you meant? Yeah, so you'd be building a system in that with the new board, which isn't quite released, but is there. If you wanted to just visualize it all happening in Scratch, for instance, when the sensor comes in, when the light sensor falls, we're simulating nightfall, covering up the light sensor, and we want the lights in a Scratch house to come on. That you can do right away right now.
Okay.
That's easy. So the sensor values, all I showed you was kind of like when the A key was pressed, but there were those, with the light sensor, there were a couple of, it went from B, C, D, E, F, G. So when the light falls down to a small level, maybe that's the G key, that would send a command to the Scratch program to make something flash or whatever. So I'm sorry, the board has 4 complete different personalities, and I kind of wanted to throw them all out there, and I'm sorry if I just like, what the heck is this? Is like that, or is it this, or could you? So, but anyway, I just kind of wanted to crash that all through, and then we can back up and specific, if this were just Scratch, you've sort of seen where it can go, but it does have these other, for instance, we were just chatting a little bit about CodeStars. Codestars. The interaction where you're writing a game in his program, but you want to integrate very simply, because the kids are learning code, some sort of physical interactive thing to shoot the asteroid, or reset the score, or turn the ship left and right, or whatever. So this opens it up at that level to Scratch and Codestars and JavaScript and any other language. So that's kind of why I did that.
Really excited about the possibilities. You mentioned the new board a couple of times. When can we expect
The hardware is ready.
Yeah.
The software is waiting for MIT to fix some bugs in Scratch. We posted bugs last August, so I don't want to be too mean to them, but they are not making extensions easy for people to use. And the extension is the way that you or I add some value to Scratch. So it works perfectly with the keystrokes, because Scratch doesn't even know where they're coming from.
So your board is ready, but it's not working necessarily with Scratch. That's what you're saying.
Yes, however, honestly, and here we are in the hallowed halls of Google, we're using Blockly, because Blockly works. Do you know what Blockly is?
Yeah.
Okay, so it currently works with Blockly. I was anticipating having this ready for this meeting, because I met yesterday with Raghu, who's doing the coding for it, and he said, I'll definitely have it ready for you tonight, blah, blah, blah. So, it's just the software that's not quite polished.
If we wanted to talk then about the CodeStars integration, then your board is ready to go.
Oh, yeah. Yeah. If you can talk to the USB port, then we don't have a problem. Scratch can't talk to the USB port in its
Figure out how to make anything happen.
Yeah. So yeah, it's completely ready. In fact, it works directly from a Chrome extension, because Chrome extensions can talk to the USB. Sorry, we're getting a little technical here, but Chrome extensions can talk, but a browser can't run an eval function in JavaScript because it's disabled. So if you write some code and you want to compile and run that code, now we're running out to the compiler, sending it on a file, sending it back, and then so we'll talk about how that can be done, but
With Scratch, it's good to go.
it's good to go in the area of keystrokes. It works absolutely 100%. Use it right now. It works like a charm. Dozens of schools are using this. They don't have any problem at all. If you want to and you can go with 8 different gradations of something. That's usually enough for an analog sensor. I should say, it's usually enough for, I want to steer my car, I want to make a theremin, I want to make whatever it happens to be. That's usually enough. But if you want to get to that higher level of granularity, or if you want outputs to function from scratch, we'll get there. But we've discovered a lot of bugs in their extension code, and they're taking some time to fix them. So that's one of the problems we're encountering. But we could certainly brainstorm it to work. And if I were to take the Scratch code, which is nicely out there, and recompile it myself, as Snap did, then that's a big job. So.
I have a question.
Go.
This is from the most profoundly non-technical corner of the room, which is, will there be a time, I'm on the Scratch page,
Okay.
but will there be a time where for teachers who are more like me, where the physical computing is just not something we have knowledge or experience with?
Right.
But let's say I want to reach in and have this experience when we're doing studying solar something. Will there be curriculum that I can grab or that I can build off of at some point? Or do you think that's your...
Okay, so the next,
I'm not
are you talking
really
about the science component or the programming component, or is that
Yes.
confusing? Yes,
Yes.
okay. So on the science side, what we plan to do is,
Because let me say, really, to that point, my whole goal in life is for those things not to live in different places.
I agree.
The reason I
agree.
see this as so powerful in a classroom, it's really the same conversation we were just having, is that I'm looking for ways in which programming doesn't stand alone,
Yeah.
but it lives in context, in curricular context.
For those,
But
sorry.
accepting that a world is made up of people, like me, who don't build things.
Okay, so I think for a beginner, yes, in those cases where the science teacher is open to Scratch, even going that far,
Yeah.
which is not as common as you think.
And I don't think it's very common.
Okay, then this is wide open. I have the same data logger you just saw here in Scratch. My trepidation is I don't want science teachers to look at the naked board and say, I'm sorry, that's not for me. I know that's an Arduino, and I can't use that because it isn't an Arduino. It's absolutely simple to use. So I don't want them even to see the board. I mean, I'm not superstitious about this. This is based on reactions that I get. So I want them to use it for science measurement. So I made a data logger, which they're totally comfortable with. It writes out to a file, comes into Excel. They're totally comfortable with that. And the board will come in a box, in a case. I have the case, so they don't have to see it. So to the degree, so that's at one end. I don't want to look at that. And so I'm totally on board with what you're saying. I just don't want to necessarily cut out 94% of the science teachers who otherwise could get value from this. So
Okay, so the
now
science curriculum is somewhere?
the science curriculum will be connected to the core curriculum points there will be about 25 different experiments you can do, from acceleration, ice water with salt in it, and we have submersible temperature sensors that work with this. Pendulums, I brought a little pendulum so we can measure the period of different lengths of the arm, pendulum arm. There will be about 20 of those little, and the curriculum's going to be shaped in the following way. It's going to be like a 3-minute YouTube. I know teachers. 3 minutes, they have no prep time. No prep time. There'll be a 3-minute YouTube, and instructable with about 5 or 10 pictures, still pictures of how to do it. Here's how to do the pendulum experiment. Put the tape here, put this here, take the little sensor, put it here, run this program on Scratch, and you'll get the results. And then there will be a pointer to the core curriculum decimal numbers. Or we were just talking about this yesterday, maybe there are 5 major textbooks out there for teaching earth science, general science, physics, etc. And we'll point to the locations where those are. I don't think we're going to write curriculum books. It's just our time is better spent doing other things. Of course, there are some good curriculums out there. They require complicated, expensive equipment to achieve that. Why would they have to do that when you can do the same experiment with a tennis ball? So that's our goal, is to facilitate that. Recognize that teachers, another curriculum is the last thing they need, but a connection between the curriculum they're using and how to do it cheaply, simply, and do it yourself, kind of, to some degree. But we plan to make this really easy, but there will be at least 20 different little videos made over the summer, 3-minute videos on how to do the pendulum, the ice water, the wind, how to make the anemometer.
And you're doing the programming in Scratch, and that will be visible, but no one will be programming. Or it won't.
Well, probably we'll do a dual thing. We'll offer it in Scratch for those 10% of science teachers who want to tinker with that. We'll offer it in this program. This is a custom program that we wrote, a data logger. Native program, does not use Scratch or anything else. It just runs as a native program. Data logger, they're familiar with this. You can run it here. And just how I did where I measured my heart rate, there will be a heart rate example where you take the number, you divide 60 by the number, that gives you what your heart rate is, that sort of thing. Take everybody in the class, aggregate that data, find the averages. It'll be that kind of stuff, but that's where it's going with that. And then there'll be a parallel thing for doing it in Scratch, because it's really fun and easy to do in Scratch. It's interesting to plot little dots or lines where the value of the sensor was over a period of time using a timer. It's actually very simple. So we will do that as well, whether we'll also give them code for processing. We have source code and processing that we also make available. It's on the website. You download it, and it gives you the full data stream of all 8 channels. You can do anything you want with it. That does what we're hoping you can do in Scratch down the line. It's not keystrokes, it's real data coming in continuously. And if anybody wants to do the workshop, I just thought more of a Scratch environment here, but it's in processing. It's the front end code that kids would have to use in processing, very, very simple and stripped down. Very easy to use, but it will give you much more speed and granularity than trying to go through the keystroke interface, which is great for one crowd and quickly outgrown for another crowd. Not quickly outgrown. All right, so I'm sorry there's all over the map, but it's so much fun to have these 4 different things out of this one board that I kind of touched on all of them. So I don't know if that ended up being a little too confusing, but after whatever Sean thinks of a break, if anybody does want to stay around and play with it, I have everything you need here to get it up and running. So, or, I'll come visit. I do a lot of school visits. I was at Bronx Academy for Software Engineering. Do you know that one? Yesterday, John Mannion, he was supposed to be here, but he didn't get here. And a lot of private schools and charter schools are using it around, and I do a lot of hands-on, whenever I can afford to sneak away from my day job, which don't rat on me. But no, I do a good job at my day job too. All right. Hope that wasn't exhausting. Thank you.